Hello students, how are you all? I hope you all are doing very well. So I am a digital science mentor and today we are going to start our new chapter, chapter number 11, force and pressure. So now let's start. If you look around, you will see many things moving. Some move slowly and some move fast. A rolling ball may suddenly change its direction. Have you ever wondered what causes these changes? A body cannot start moving or stop moving, change its direction or shape on its own. This happens because force is applied to the body. Let us learn what is a force. So now let's see force, a pull or a push. We use force to perform various day-to-day activities. When we pull or push an object, it moves. We need force to move them. Now let's see pull and push are forces. A pull or push acting on an object is called force. Force is usually denoted by the letter capital F. The standard unit of force is called Newton, denoted by capital N. Force does not always move an object. For example, you can push ball without displacing it from its position. Here you can see the picture in which you can see push and pull are forces that make things move. Let us understand force with examples. Force as a push when an object is moving away by applying force. For example, pushing a door to open it. A lady pushing a trolley. A vegetable vendor pushing a vegetable cart. A boy kicking a football. Force as a pull when an object is moving towards the applied force. A horse exerts a pulse to move a tonga. Pulling a door to open it. Next, drawing a bucket of water from a well. Opening a drawer of a table. And the amazing fact is that in general, more than one force may be acting on an object. However, the effect on the object is due to the net force acting on it. Now, forces are due to an interaction. We have seen that when force is applied, either push or pull, there is some kind of change in the state of motion of the object. Let us see when does force come into play. Suppose there is a car which is not starting. Now, if you stand behind the stationary car, it will certainly not move. Here you can see the first picture in which a boy standing behind the stationary car, and in the second picture you can see that a boy that is pushing the car. Now if you push the car, that is force is applied. Car will begin to move in the direction of applied force. When we kick a ball or pull a cart, interaction of two objects is required. So here you can see the picture, a boy kicked the ball, and in the second picture you can see a cart being pulled. Thus, we can infer that at least two objects must interact for a force to come into play. We can therefore say that forces are due to interaction of one object with another. In most cases, like kicking a ball, pushing a cart, pulling a drawer, the force and the object come in direct contact with each other. Such forces are called contact forces. However, interaction may not always involve a direct physical contact. Such forces are called non-contact forces. For example, magnet attracts iron object without coming in direct contact. Now let's see the type of forces. There are two kinds of forces. First is contact force and second is non-contact force. So now let's see what is a contact force. Forces that act on object by direct or indirect physical contact are called contact force. The following are some kinds of contact forces. Here you can see that the first is muscular force. The force exerted by the action of muscles in our body is called muscular force. Examples: when we lift a bucket of water or push a cart, kick a ball or walk or run, we use muscular force. Digestion of food, bending of our body, breathing are all carried out due to the force exerted by the muscles. So here you can see some pictures which is showing example of muscular forces. So now let's see the amazing fact. What is it? Animals like bullocks, horses, donkeys and camels also use muscular force to do heavy work such as pulling a cart or a tonga, plugging, carrying heavy load, etc. So now let's see friction. Friction is also a type of contact force. The force acting between two surfaces in contact with each other which opposes the motion of one body over the other is called friction or force of friction. The force of friction always acts on all moving objects and its direction is always opposite to the direction of motion. Example, a rolling ball comes to rest after some time due to the friction between the ground and the surface of the ball. A cycle stops after some time. If you stop pedaling because of the friction between the road and the cycle. Now let's see next topic, that is non-contact forces. Forces that do not need physical contact on the object on which they are acting are called non-contact forces. Magnetic force, electrostatic force and gravitational force are examples of non-contact forces. So first we will see magnetic force. To understand magnetic force, let's do activity. So now let's try to understand what is it in this activity. Bring a magnet near iron nails, what happens? Bring two magnets with like poles near each other, what do you observe? Now bring two magnets with unlike poles near each other, what happens? You will observe that a magnet attracts nail even though it is not direct contact with the nails. A magnet attracts to another magnet when unlike poles. Remember that unlike poles are brought near and repels another magnet when the poles are brought together. When like poles are brought together. So this activity shows a magnet exerts force on another magnet without being in contact with it. The force exerted by the magnet is called magnetic force. So now let's see electrostatic force. The comb acquires an electrostatic charge after it has been rubbed on the hair. The force exerted by a charged body on another body is called electrostatic force. This force also comes into play when the two bodies are not in contact with each other. So now let's see the another force, that is gravitational force. Every object in the universe, irrespective of its size, exerts a force on every other object. This force is known as the gravitational force. Example, when the ball slips from your hand, it falls down. Fruits and leaves fall on the ground. Water in river flows down. All objects fall down towards the earth. This is due to the force of gravity. So here you can see some picture which is showing the force of gravity. So now let's see the another topic, that is resultant force. At times more than one force acts on a body at the same time. In such a case, the effect on the object is due to the net force acting on it. So when both you and your friend move the table in the same direction, it can easily be done and more faster than when you alone had to do it. In the second case, table will move in the direction more force is applied. Thus, we can conclude that when two forces act in the same direction along the same line, the resultant force is equal to the sum of the two forces. And when the two forces act on an object in opposite direction, the net force acting on it is the difference between the two forces. So, you must have seen a game of tug of war when the two sides pull the rope hard. It does not at times move in any direction. This is because the resultant force, net force acting on it, is zero. So here you can see the picture in which the rope does not move if the two teams pull at it with equal force. If the direction or the magnitude of the applied force changes, its effect also changes. So now let's see effects of force. So first we will see a force can change the state of motion or rest. When you kick a ball at rest, it moves. In other words, force can make a stationary object move. Suppose a ball moving on the ground slowly. If you push the ball while it is still rolling, what do you observe? Its speed increases. This shows that a force can increase the speed of a moving object. If you catch the ball, it stops moving. Therefore, we can say that force can stop a moving object. A bicycle can be slowed down or stopped by applying brakes. Force can decrease the speed of a moving object. Here you can see the boy who is playing with a football by using force. So, we can conclude from the above two examples that if the force applied on the object is in the direction of its motion, the speed of the object increases. If the force is applied in the direction opposite to the direction of motion, it results in decrease in speed. So now let's see the second point, which is a force can change the direction of motion of a moving object. Let us understand this with the help of examples. First, a football player kicks the ball in a different direction. A batsman hit the ball at him, and a badminton player hits the shuttlecock either softly or smashes it on the other side of the court. Thus, a force may bring a change in state of motion of an object. State of motion means the speed and direction of motion. The two states of motion are rest and in motion. At times, you may apply force, but it does not result in a change in the state of motion. You will not be able to move a ball irrespective of the amount of force you apply. So now let's see the next point, which is a force can change the size and the shape of an object. So now let's try to understand with an activity. Take a plasticine or dove, press it down with the hand. Next, take a rubber band, stretch it. Next, squeeze toothpaste out of a tube. Press an inflated air pillow. And next, pull a string. What do you observe? Is there any change in size and shape or both? Note down your observation. So now let's see. Here you can see the table in which you can see the observation. First, read the description of activity and then see the change in size or shape. First, pressing plasticine or dove. Yes. Change in size and shape there is present. Now, next, stretching a rubber band. Of course, the size will change and the shape is also changed. Squeezing toothpaste out of the tube. The change in size and shape will be there. Next, pressing an inflated air pillow. Changes? Yes. Next, pulling a spring. Of course, changes will be there. Now, can you add some more examples to the list? This is your activity you have to do. Now, in all the above objects, we see that when force is applied on an object, in all the above examples, we can see that when force is applied on an object, its size and shape changes. We can thus conclude that force can move a body at rest. Force can make a moving object move faster. Force can slow down a moving object. Next, force can stop a moving object, and force can change the direction of a moving object. So I hope you have understood what is a force. So now let's see pressure. Force can change the shape of an object. The force acting on a unit area of a surface is called pressure. Here you can see the formula. Pressure is equal to force upon area on which it acts. So the standard unit of force is Newton and the standard unit of area is meter square. Force upon area is the formula of pressure. You must have experienced that cutting a fruit with a sharp knife is easier than cutting it with a blunt knife. When you apply pressure on the broader end of the drawing pane, it pierces into the cardboard. All these are due to effect of force in respect to the area it's act on. In other words, it is pressure. This shows that pressure exerted is irreversibly proportional to the area of contact. That is, the pressure produced is less if the area over which force is exerted is large. Decreasing the area over which a particular force acts increases the pressure produced. The area of the pointed end of the drawing pin is much smaller than its head. Therefore, when we apply force on the head, needle is inserted into the cardboard. Similarly, it is easier to cut fruits with sharp knife because the area contact of sharp knife is much less than that of a blunt knife. This also explains why a camel is able to walk easily on sand, as it has flat, broad feet. On why do potters or person lifting heavy loads place a turban, that is round piece of cloth, on their head before placing heavy loads? The turban increases the surface area of contact of the load with their head. This is turn reduces the pressure on the head. Now let's see the amazing fact, which is the unit of pressure is Pascal, that is also denoted by small pa. It is named after the French scientist Blaise Pascal. So now let's see pressure exerted by liquid and gases. Both liquid and gases exert pressure. So now let's try to understand with an activity. Take a tin can or a plastic bottle, drill a few holes all around it near the bottom. The holes must be at the same height from the bottom. Fill the bottle with water. What do you observe? Water rushes out from all the holes and falls at the can distance from the can. Here you can see the picture in which you can see that liquids exert equal pressure at the same depth. So now this shows that liquid exert equal pressure in all direction at the same depth. So now let's see the another activity in which take a tall can, empty talcum powder can. Make 3 holes in it on one side at different heights. Fill the can with water and observe what happens. Water from the lowest hole comes out with the greatest pressure and hence it travels maximum distance, whereas water coming out from the highest hole falls nearest due to least pressure of water. Water from middle hole falls in between. Here you can see the picture which is showing pressure in a liquid increases with depth. This activity shows water pressure increases with the depth of the water. So now this activity shows that liquid exerted equal pressure in all directions. This is called Pascal's law. So now let's see the next topic, that is pressure exerted by air. Gases like liquids also exert pressure. So now let's try to understand with an activity. Take a balloon, inflate it, leave the mouth opens. What happens? The air moves out and the balloon deflates. Take a balloon, prick it with a needle to make holes. Can you fill air in it? No. The above activities show that the air exerts pressure in all directions and also on the walls of the container. So now let's see the next topic, that is atmospheric pressure. We have already studied that Earth is surrounded by air. This envelope of air is called atmosphere. Air is a mixture of gases. Like gases, air also exerts pressure on Earth due to its weight. Atmospheric pressure is defined as the pressure exerted on an object by the weight of the air above it. Air pressure is maximum at sea level. It is about 100,000 Pascal. Air always exerts pressure on the human's body because of the tall column of air above us. Do you feel this pressure? No, this is because the pressure of the blood and that of fluids in our body balances out this atmospheric pressure. So now let's see. Otto van Guericke, a German physicist in the 1600 demonstrated air pressure. He joined 2 hollow semicircular bowls made of copper of semi-diameter and removed the air inside with the help of suction pump. He got a team of 8 horses each to pull each hemisphere apart. The 2 balls held together and they could not be pulled apart, showing the enormous force of atmospheric pressure. Here you can see the picture in which horses pulling the hemisphere. Air pressure is measured by an instrument called the barometer. It was discovered by an Italian scientist, Torricelli. Atmospheric pressure decreases as we go up in the atmosphere. This is because as we go up, the length of the air column decreased, hence atmospheric pressure also decreases. Mountaineers at high altitude at times experience bleeding through their nose. This is due to the rupturing of blood vessels in the body due to sudden decreases in air pressure. And the amazing fact is that the weight of an atmosphere on top of your head is about 225 kilograms. So students, I hope you have understood this topic. So now let's wrapping it up. Let's see some points. Forces is due to an increase. Forces is due to an interaction between two objects. Force has both direction and magnitude. Force are of two types, contact force and non-contact force. Pressure in liquid increases with depth. Pascal's law states that when pressure is applied to a liquid, it gets transmitted equally in all directions. The pressure exerted by air around us is called atmospheric pressure. Atmospheric pressure decreases with altitude. Atmospheric pressure is measured by an instrument called barometer. So I hope you have understood these points. So now let's see some keywords. So first we will see what is a force. Any push or pull which moves a thing is called force. Magnetic force, the force of the magnet which attracts some metals like iron, etc. towards itself. Next is mechanical force. Force generated by a machine is called mechanical force. And then we'll see muscular force, force produced by the muscles of any living organism. And next is a manometer, device to measure the pressure exerted by liquid. And next is pressure, the force per unit area. So I hope students you have understood all of these topics and enjoyed this chapter. So now I will meet you in the next lecture with a new chapter. Till then, revise this chapter and keep learning. Thank you.